So far, we have discussed the various other techniques for solving the problem of finding the first and last occurrence of a particular target value in a sorted array of values that are being given, right? Now, in this video, let's quickly write the binary search based implementation of the same thing. So for that, here I have created a new file, first and last occurrence in a sorted array, and here I have also created the class, and I have added the main method and whatever the base class that we need to do and the function that we need to use, that I have already added here. Now let's just try to write the solution for this. For that, let me just close all these other pages that I have kept open. Here first, let me just read the length of whatever the array of values that we have been given. Once we have this length, here ultimately what we can do, we can simply check if at all the length is equal to 0, that means that the array is empty. In that case, what we will do, we need to return -1 and -1, right? Here one thing that you need to remember here is we need to return the first occurrence index and the last occurrence index. That means we need to return two values. That's the reason why in the end also we will be returning a vector containing two values. So the return type of the function will also be vector of int. So here to return that, what we will do is we will return a vector of int containing -1 and -1. Okay, so since the array is empty, the value could not be found, so we return -1 and -1. If this is not the case, then we basically have some number of values inside the array. So before going there, maybe this way of returning might be little confusing to you. Here what you can do is you can simply create a variable result. Okay, in the end you can just return the result as well. It is completely up to you how you want to return. Okay, now here let's try to handle the other scenarios. Here, since we are going to use binary searching for finding the first and last occurrence, I'm going to define couple of helper variables. Int starting, I'm going to initialize it with the 0, and I'm going to initialize it with the last index length -1. Similarly, let me just calculate the middle. This I'm going to initialize it with -1. Here, to hold the first occurrence of a particular target value inside the array, I'm going to define one variable called first occurrence index. This I'm going to initialize it with -1. So here our ultimate aim is to find the first occurrence of this target and assign that index to this particular variable. So for doing that, what we will do is we will run a loop as long as the start is less than or equal to end. Here first we will calculate the middle. The middle will be start plus end divided by 2. Okay, once we calculate the middle, whatever the value we have at this middle index, we will be comparing it with the target value we have been given. Okay, if at all the value at the middle is matching with the target value that we have been provided, right, that means whatever the middle index that is there, it could be the first occurrence of that particular value. That's the reason why the first occurrence index variable, whatever we have defined, we will simply update it with middle value. Now remember, we are trying to find the first occurrence. So far we have found the middle and it could be the first occurrence, but there is still a chance that this value could be still visible on the left part of the array, right? Because we are trying to find the first occurrence. So to continue the search on the left part of the array, whatever the end that we have defined, we will simply be initializing it with middle -1. Okay, so our search will still continue and will still calculate the middle and will compare it again, and we will continue the comparison logic. If that is not the case, if at all the value we have at the middle, so here we have compared for equal to scenario and the other scenarios are greater than and less than, right? If the value we have at the middle is greater than the target, that means the target is smaller than the middle. That means it will be somewhere on the left part. For that, here we will simply update the end with middle -1. Okay, if this is not the case, obviously the other scenario is the value we have at the middle is smaller than the target value. In that case, the value could be available on the right part of the array. To continue the search on the right part of the array, we will need to do we will need to update start with middle plus 1. Okay, once we complete this while loop, if at all this target value is available, it will be available inside the first occurrence index. Okay, now similarly, however we have calculated the first occurrence index, we need to calculate the last occurrence index as well. So for that, here let me just reinitialize the first start with 0, end with length of the array -1, and middle also back to -1. Here to hold the last occurrence, however we have created the variable first occurrence index, right? Similarly, we will create the last occurrence index as well. Here our aim is to update this last occurrence index variable with the actual index from the array. Here ultimately we will run the same while loop whatever we have run for calculating the first occurrence index. Once we calculate the middle, we compare the middle value with the target, right? If at all the middle index value is matching with the target, it could be the last occurrence index. So here, instead of updating the first occurrence index with middle, we will update the last occurrence index with the middle value. Now here is some other modification that you need to do. The middle is matching with the target value. Now since we are trying to calculate the last occurrence will always be there on the middle or on the right of the middle. To continue the search on the right part of the array, here we will simply update the start with start plus 1. Okay, so that is the important modification. If that is not the case, that means if at all the value we have in the middle is greater than the value that we have at the target, in that case we need to search on the left part of the array. So the end will still remain middle -1, and otherwise the start will still remain middle plus 1 to continue the search on the right part of the array. Okay, so that is what it is. We have separately independently applied binary searching twice to find the first and last occurrence of an index. Here one more thing is, to find the last occurrence index, basically we no need to start from index 0 as well, because if at all the first occurrence index is not -1, we can start the binary searching from first occurrence index to the last index we have in the array. If at all if you want to do that modification, you can do that in the solution. That I will leave it up to you, if at all if you want to do. Here in the end we need to return the vector containing first and last occurrence index, right? So here let me just define a vector containing first occurrence index and last occurrence index. Okay, we will simply return this result. Okay, so that is how we find the first and last occurrence index in a sorted array of values that we have been given. Remember that here the array of values are sorted in the ascending order. If at all if you want to find the solution in a sorted array of values which are sorted in the descending order, you need to apply the opposite logic. Okay, so that I will leave it up to you, if at all if you want to try it out as well. Now let's just call this function. To call this function, let me just create the object first and last occurrence, flo dot first and last occurrence in a binary search. Let me just pass the array. Along with that, let's just say I want to search for the value 5, and in the end this will return a vector of int. Let me just store it in one variable result. Here let's just do cout result of 0. Okay, and let's just do result of 1, and let's just do the end line. Okay, so if you look at the array of values we are passing, they are sorted in the ascending order, and the first occurrence of 5 is available at index 4, and the last occurrence is at index 5. So if I run this code right now, 4 and 5 should be the output. Okay, see, 4 and 5 is what we have got on the console. Similarly, let's just say here instead of 4 we have the value 5. So first occurrence is at index 3 and the last occurrence is at index 5. So that is what we have got as well. Let's just say I want to search for a value which is not repeating. Let's just say I want to search for the value 3. the value of 3 is appearing only once. That means it itself is the first and last occurrence, right? So the first and last occurrence will be index 2. If I run this right now, the output is 2 comma 2. Let's just say I'm searching for some value which is not there in the array itself. So in that case, obviously it should return -1 and -1, which we have got. Okay. Similarly, you can just make the array empty and you can run the program as well. Here also we've got -1 and -1. Okay, so those are some of the common test cases that we need to evaluate our implementation against. If at all, if you want a couple of other scenarios, you can check out codingpal.org. There I have mentioned some of other test cases as well. If at all, if I have missed evaluating those test cases, you can evaluate from there as well. Okay, moreover, if you want to try out any other solution using any other approach that we have discussed in the algorithmic section, they are also available in the code snippets part of the same problem that you can reach by using the link in the description box below. Okay, so that's it for this first and last occurrence index. I'll see you in the next problem.